Hi, welcome to the Olympiad geometry. Let's continue our study of the Ceva theorem. Let the opposite side of a convex quadrilateral ABCD intersect on E and F. So we can see ABCD here. The opposite side, that's AB and CD, intersect on point E, and BC and AD intersect on point F. Diagonals intersect on P. BD, AC intersect on P. O is on EF, and PO is perpendicular with EF. Proof: angle BOC equals to angle AOD. This problem is much harder than the problems we see in previous videos. So how can we solve this one? We know that PO is perpendicular with EF, which means we already get a 90-degree right angle here. That's POF or POE. So we can guess we want to prove that the angle BOC equals to angle AOD. Maybe not only angle BOC equal to angle AOD, but also BOE equals to angle DOF. We don't know. So how can we prove this? As what we learned before, we can find the triangle and use the Ceva theorem and transfer it to the ratio of the area, and then find the relation between angles. So for the similar pattern of the method, we need to find the proper triangle first. So here, if we look at ABCD, we know that we can. So if we just look at the triangle ABD, okay, ABD. So we know that AP, BF, and DE are concurrent on point C, right? So we have ABD and point C, right? And also we have BCD. If we look at BCD, so that means C, from the vertex C, we draw a line to the BD, right? We draw a line to the BD, that intersect BD on P, and that's a CA line. And from point D, we can draw a line to BCD, right? To BC, from the vertex D, we can draw a line to BC. That's actually DF. The DF intersect CP on point A, and from point B, we can draw a line that intersects CD, right? That's a point, that's a BE, right? From B, we draw a line to CD, that's BE, and it extends the BE. It also intersects CP and DF on point A, which means we have triangle BCD and point A. What else? If we look at the triangle BCA, so we draw a line from vertex A to the BC side, that's AF. And we draw a line from vertex B to the CA side, that's BD. Right? So BD, AF. These two lines intersect on point D, and from vertex C. Yeah, from vertex C, we draw another line. B, we want to find B, C, A, right? So A here and B here. Yeah, from C, we draw another line to the side of AB, that's CE, and extend CE. It intersects other two lines on point D. So the triangle BCA and point D. Similarly, if we check the triangle ACD, so ACD, from point A, we draw a line, intersect CD, that's a AE line, right? Intersect the intersect the CD, that's a AE line. And for the from the vertex D, we draw a line intersect AC, that's BD, which means AEBD intersect on point B. And from the vertex C, we draw a line to AD side, that's CF. It also intersects on point B. So that's point B. In the end, we can prove that any two of this set, let's call this as first set, and this as set 2. So either set 1 or set 2 can solve the problem. But let's just pick up one. Okay, let's choose this set, the triangle ABD and point C. So we got ABD here. And point C, we can use the Ceva theorem on this. So we have, look at it, ABD here, right? So the line on the line from vertex A is AC, from B is BF, from D is DE, right? So we use this first, and then we can do the second one. They're the same. So we have AE divided by BE times BP divided by DP times DF divided by AF equals to 1. Right? This comes from Ceva theorem. And for the triangle BCA and point D, BCA and point D. So here is the thing. We can choose any triangle point of the first and then the second, any of them. We can solve that. So eventually we have like 2 choices here, 2 choices here, 4 different choices. Any of the choice can solve this problem, but let's just pick one of them first. So BCA and point D. BCA and point D. That's like from vertex A, we have AF, right? And from vertex B, we have BD. From vertex C, we have CE. So we got AE divided by BE times BF divided by CF times CP divided by AP equals to 1. I will explain later why we want to do this. Okay, let's just check this first. We have this one, the triangle ABD and point C, we got this Ceva theorem, through Ceva theorem, we got this equation. And we can extend this equation, the term AE to BE, AE to BE. That's in the triangle AOE and BOE, right? So we can assume this triangle, the angle of BOE is alpha, and we have another angle here. That's, see, we want to have we have the AOE, so that's an angle AOE. But because angle POE is 90 degree, so angle AOE can be written as 90 degree plus angle POA. That means we can just set the POA to be a angle we want to find out, right? So let's set angle POA equals to gamma. Okay, so angle BOE equals to alpha. This is alpha, this is gamma, POA is gamma. And we have another term that's BP to DP. BP to DP, right? BP to DP. That's the angle BOP, which is 90 degree minus alpha, right? So we don't have to write an angle for this one. And another angle DP, that's the angle POD, right? POD, similar to here, so we just write this one as beta. Angle DOF as beta. Then we know POD is 90 degree minus beta. And we have DF and AF. AF, because this is gamma, AF is 90 degree minus gamma. That's the angle AOF, right? AOF is 90 degree minus gamma. And for the DF term, that's relevant to the angle beta. So we got all of them. Then we can just write this AE divided by BE times BP divided by DP times DF divided by AF equals to 1. And this, from this, we got AE to BE. AE to BE, that's the angle, that's the area of AOE to the area of BOE, right? And we just put O here. So we got BOP to DOP and DOF to AOF must equal to 1. So what is AOE? That's half AO EO and sine angle AOE. As we said, angle AOE, that's 90 degree plus POA plus gamma, right? So sine pi by 2 plus gamma divided by BOE. BOE, that's BO times EO times sine alpha. And the triangle area BOP, so BOPO sine BOP, sine BOP, angle BOP is 90 degree minus alpha, so sine BOP, sine 90 degree minus alpha, that's cosine alpha. So we directly write it as cosine alpha. And also for the PD, we have DOP, right? So that's DO times PO times the angle POD, right? 90 degree minus beta, so it's cosine beta, times half DOF, so DOFO sine beta. And AOF, that's half AOFO times sine. This is gamma, POA is gamma, AOF equals to pi by 2 minus gamma. Right? This equals to 1. This equals to 1. So we cancel EO, we cancel all the 0.5 term, EO, PO, FO cancels, right? And we see AO cancelled, BO cancelled, and DO cancelled, right? So what we have here, we have a sine pi by 2 plus gamma, that's cosine gamma. We have sine pi by 2 minus gamma, that's cosine gamma. So these two cancel each other. Then we got only cosine alpha sine beta. Divided by sine alpha cosine beta equals to 1, which means we got that alpha equals to beta, right? So angle BOE equals to angle DOF. Now, if we look at, let me explain why we want to have these triangles here, right? So from the triangle ABD or the triangle BCD, we can have the conclusion that alpha equals to beta. And we need to find, so we want to prove that BOC to DOA, which means we want to put the OC, OP, OA into our equation, right? So if we want to find the OC, OA, and OP, we have to find a way that we put the CP to AP into this equation, and the ratio of CP to AP must come from one side of a triangle, that either the triangle ABC or triangle ADC, right? So that's why we want to find either ABC here or ACD here. Either of them can help us find the AP to CP ratio, right? So let's do this. Similarly, AE divided by BE times BF divided by CF times CP divided by AP equals to 1, right? What we got here. AE to BE, again, we just put O inside of it. So that's the area of triangle AOE to the triangle BOE and the triangle BOF to the triangle COF and the triangle COP to the triangle AOP, right? Equals to 1. So we got half of AO times EO times, so this is similar, I directly write it, so cosine gamma divided by, this is the same, right? Because it's AE to BE. A to B here, so half of BO times EO times sine alpha, and times BF to CF, BF to CF. What is BF? So that's the area of BOF, right? So BO times OF times sine this one. Sine this one is sine pi minus alpha, so it's sine alpha. So we got half times BO times OF times sine, I'll just write it again, pi minus alpha, right? It's sine alpha. And we have COF here, COF here. So now we have to bring another angle COP, right? We already set the POA to be gamma. Let's set POC to be theta. So we have half times, because this is a triangle COF. COF, that's CO times OF times sine angle COF. Angle COF is 90 degree plus theta, right? So sine pi by 2 plus theta. And COP, that's CO times PO times angle COP. So COP is theta, so sine theta. Also half AOF. Sorry, AOP. AOP, that's AO times PO times sine gamma equals to 1. So what we got here, sine pi minus alpha, that's sine alpha, right? So sine alpha cancels sine alpha. And sine pi by 2 plus theta, that's cosine theta. So we cancel all of these 0.5 terms, and BO cancels, EO cancel, OF cancel, PO cancel, AO cancel, AO, CO cancel, CO, right? So finally we got cosine gamma times sine theta divided by cosine theta times sine gamma equals to 1. So this means cosine theta minus gamma equals to 1. So, sine theta minus equals to 0. That's theta equals to gamma, which means COP and AOP are the same. So because COP equals to POA, that means COE equals to AOF, because PO is perpendicular with EF, the angle POE is 90 degrees, right? And we minus COP from left side, and from the right side we use 90 degree minus POA. We got the two angle of COE equals to angle AOF. And because alpha equals to beta, so the angle BOC equals to the angle DOA. And we prove this. And you can find that from the first side, right, the triangle ABD or triangle BCD, we can always have the conclusion that alpha equals to beta, because the ABD or BCD, they all have the ratio that relates to the angle alpha beta, and another angle of theta or gamma, they cancel, right? And then we want to find the relation of theta and gamma. We have to include the ratio of the CP to AP, which means that AC must be a side of the triangle. So we can either choose ABC as a triangle or ADC as a triangle. And then we can solve this problem. So I would say this problem is a little bit harder than the previous problems, because you have to think about use the Ceva theorem twice and figure out what is the proper triangle you want to use for the Ceva theorem, and find the proper angle relation first. Right here we find the alpha beta equals to beta, and then we can solve to the next stage, because here we want to cancel alpha beta. Okay, this is a problem, and hope you like this video. See you in next one. Thank you.